Hope you all can see my screen as well. Okay, hope you all can see my screen as well. So let us start with why we need the cloud platform. Okay, so let me gonna take to the next slide, guys. So assume that there's a company. Let me say a Flipkart company is there. Let us take a one simple example. Assume that you have a company called Flipkart. Okay, that company wanted to create a new application. What they wanted to do? They wanted to create a new application from the scratch, right? So what happens behind the scene if one organization wanted to create a new application for their users? So let us try to see how it works with a traditional working model, how we are going to see how we are going to work now in the cloud era. So let us try to see the difference between both of them. Okay, so this is what it is, guys. So assume that a company wanted to roll out a new application. Okay, so whenever a company wanted to roll out a new application, the business comes up with a requirement for the application. There will be a different business managers will be there. So they're gonna connect with the requirements and they're gonna find or they're gonna come up with the requirements for the application. So what and all the application need, how it has to serve, all of those details they are going to get. So in terms of a business point of view, now that information you will usually passes to the business analyst. Now the business analyst will come into the picture. He will gather all the needs from the business and analyzes it and converts it into a set of high level technical requirements. Okay, so there will be a business. Our business comes up with a requirement for the application, and the business analyst will gather the needs from the business and analyzes that information and converts it into a set of high level technical requirements. Then he passes that information to the solution architect. Okay, so he will passes that information to the solution architect. Now the solution architect will design the architecture to be followed for the application deployment. 1 minute, guys, I see a diff. Sorry, guys. So whenever an application whenever an organization wanted to roll out a new application, the business comes up with a requirement for the application, and that requirements will be analyzed by the business analyst, and he gather all the requirement from the business and analyzes it and converts that into a set of high level technical requirements, and then he passes that information to the solution architect. Now, the solution architect will design the architecture to be followed for the architecture diagram. So he will prepare an entire architecture diagram for the application deployment. That may involve what kind of a programming language that they are using, and what is an application, or what is the infrastructure they are doing, what is the number of servers that they are used for the front end web server or the back end web server or the databases or the load balancers. So if you wanted to deploy one application, whatever the things that are required, the solution architect will create an architecture diagram to be followed. So in that architecture diagram, everything will be there. Starting from the scratch to the end of the deployment, whatever that is there in that architecture diagram will be there. So what kind of a programming language they are using, what is the runtime, what are the servers, how many servers required, the backend databases, front-end databases, load balancers, the specification type, the deployment strategies, everything will be involved in that particular solution diagram or an architecture diagram. Okay, whenever the solution architect creates this architecture diagram, what happens is that if you are following a traditional working model, okay, if you are following the traditional working model, these all should be deployed in the on-premises environment only. Okay, if you go 10 years before, we do not have a cloud platform. So if you do not have a cloud platform, who has to take care of your infrastructure? Tell me, guys, who has to take care of your infrastructure? Who has to create the servers? Who has to create the load balancers? Can you guys tell me? Right. So if you wanted to create it, the company has to do that. Right. The company has to manage their own infrastructure. The company has to manage their own number of servers. Everything has to manage it. So that is the reason at that point of time, most of the companies has its own data center. Okay, the company is going to be having their own data center in the company on premises. So in that particular data center, whatever the architecture diagram, for example, if I say a load balancer, or if I say a servers, or if I say any other infrastructure such as hardware, software, anything. So whatever it is required for the architecture diagram, so all of those things has to be available here. All of those things has to be available in the data center. Okay, because you are creating an application. If you wanted to provide your application to the users, that application has to be deployed. For that deployment, you need the entire infrastructure. That may involve the load balancer, or the number of servers, or the front-end web server, or a back-end web server, or any other infrastructure. All of those things has to be available in the data center. What is a data center? If you ask me, a data center is a collection of infrastructure or a collection of resources. That resources can be a physical resources or a virtual resources. In a data center, you will be managing two types of resources: physical resources as well as virtual resources. So who is maintaining this data center, guys? Who has to maintain this data center? The company has to maintain the data center. The company, the organization has to maintain this data center. Now, assume that whatever he has mentioned in the infrastructure, in the architecture diagram, if that is not available in the data center, what the company has to do, sir? Can you guys tell me? The infrastructure that is required for the application deployment, new application deployment, if that is not available in the data center, okay, what the company has to do, guys? They have to purchase it, right? They have to purchase it. So that is the reason the solution architect will create a request to the procurement team. The solution architect team will create a request to the procurement team. What they try to mention is that they want some kind of infrastructure, but that is not available in the data center. Okay, so that's where the solution architect will create a request to the procurement team. The procurement team will connect with the vendors team. Procurement team will connect with the vendors team. Now the vendors team will take a lot of time, because whenever you have a additional hardware is needed, they would have to order it via procurement team. Now this team will put in a request to the vendors team. Now the vendors team will take days or weeks or even sometimes months for the hardware to be purchased and deliver it to the data center. They have to purchase the entire things and they have to deliver it to the data center. So this is how they have to do it. Okay, so what happens if the entire infrastructure is already available in the data center? There's no problem, but most of the times that entire infrastructure is may not be available in the data center. The solution architect team will create a request to the procurement team. The procurement team will create a new request with the vendors team. Now this they will take a lot of days or weeks, sometimes even months also, for the hardware to be purchased and deliver it to the data centers. Once the hardware is received at the data center, once the hardware is received at the data center, that's where the infrastructure team, not such as the field engineers, will come into the picture. The field engineers are in charge of rack and stack for the equipment. Okay, the field engineers will come into the picture and they make sure that they create a rack and stack with help of these hardware. After that, the system admins will come into the picture. They will do the initial configuration of the system. And the network admins come into the picture and they will make the systems to be available over the network. Right? The system admins will take care of the initial configuration of the system, as well as the network admins make sure that the systems are available over the network. And the storage admins will make sure that the storage is assigned for each and every server. And the backup admins will take care of the backup. They will configure the backup. Finally, once the system has been set up as per the standards, it can be handed over to the application team for the deployment of their application. Okay, so this is what is the entire traditional architecture, guys. In a traditional working model, so everything has to be taken care by the company only here. So all of these things for a new application deployment, the company has to take care of all of these things. Okay, look at here. If you wanted to create a new application, the business has to come up with the requirements. The business analyst will analyze the information, converts that into a technical requirements, and passes that information to the solution architect. Now the solution architect will create an architecture diagram to be followed for the deployment of the application. If the infrastructure is already there in the data center, there is no problem. But most of the times the data center is not having the infrastructure required. They have to create a request to the procurement team. Procurement team will connect with the vendors team, and vendors team will purchase the hardware and deliver it to the data center. This will take a lot of time again. Now, once the hardware is received at the data center, the field engineers will take care of the initial field engineers will take care of the equipment rack and stack. System admins take care of the system configuration. Network admins make sure the networks are properly plugged in, and the storage admins will assign the storage. They will backup admins will configure the backup for each and every server. Now, once everything is set up as per the standard that is mentioned in the architecture diagram, that will be handed over to the application team. The application team will do the deployment of their code which they have developed. Okay, so this is what is a traditional working model, guys. So this is how people used to work. This is how people used to work. Sir, I see that everything seems very good. But what is the problem, sir? What are the problems that they are facing? I see that everything is flowing very good. I don't see any problem. Sir, what is the problem that they are facing if you ask me? So if you look at here, if I wanted to create a new application, I have to follow each and every step. Okay, for an application deployment, I need to take a lot of time here. For application deployment, the turnover time varies from the weeks to months to everything to be ready for the application deployment. So that is the reason you see here, guys. So if I wanted to create application, everything has to be followed. If the infrastructure is not available, it takes days, weeks, and months also. So that is the reason the turnover time varies from weeks to months for the everything to be ready for the application deployment. So that is the reason it is called as a slow deployment model. It is called as what, sir? It is called as a slow deployment model. Okay, so it is called as a slow deployment model because it is taking a lot of time. And one more is it is very costly. The overall cost to deploy and maintain this working model is very high. I would say it's because you look at here, we have to maintain the data center. So maintaining the data center means 24/7 electricity, 24/7 cooling supply, 24/7 security persons available. The admins has to take care of the upgrades, patches, and all of those things. So everything. So a lot of money has to spend here. And we need to have a procurement team, vendors team. We need to provide the salaries for the field engineers. This many people we need to. So that is the reason the overall cost to deploy and maintain this working model is very high. And one more problem is that, so that's the reason it is an expensive working model. And one more problem is that limited automation. Some aspects can be easily automated, but most of the steps cannot be automated. Can we automate the data center things? No. Can we automate the procurement things? No. Vendors things? No. Purchasing, can we automate? No. We can't automate the purchasing things and delivery things. Okay, cannot be automated. So most of the things, field engineers, what they are doing, rack and stack, cabling, networking, cannot be automated at all. Okay, so it is a limited automation. If you wanted to create your infrastructure, the automation is limited. So that is the reason, the while some aspects can be easily automated, but most of the aspects cannot be automated at all. So that is the reason we call it as a limited automation. And one more is human error. With so many teams working behind the scene on a different activities, you have a field engineers team, system admins team, network admins team. So you have a plenty of teams working behind the scene on a different task. The chances of human error is very high, which leads to the inconsistency in the environment. Okay, it's because that many teams are working on a many different tasks. The chances of human error is very high, which leads to the inconsistency in the environment. And another one more major disadvantage is that wasting the resources. So underutilization of the compute resources is one of the biggest disadvantage in the traditional working model, because you may be purchasing a lot, but you are not going to use a 50% of it also. So that is a major disadvantage in the traditional working model, guys. Okay, so the problem with the traditional working model is that the working model is slow, it is costly, limited automation, human error is very high, and the chances of the inconsistency is there, and underutilization of the compute resources. Due to this many disadvantages over the past decades, the organizations were looking for an alternative solution. So that's where the cloud platforms came into the picture. That's where the cloud platforms came into the picture, and they are providing you the infrastructure so that you don't need to maintain the data center first thing. Okay, because the entire infrastructure is already provided by the cloud platforms itself. You don't need to have the field engineers. You don't need to much worry about the system admins, network admins, storage admins, backup admins. You may have to configure them, but it is not that you are going to take care of entire thing. Most of the things are taken care by the cloud platforms itself. You don't have a procurement team separately for the infrastructure. You don't have a procurement team separately for the vendors team. You do not have this team, no, this team, no, this team, no, this team, no, this team, no. This entire things are no. So it's because that the entire all of these things are taken care by the cloud platform. So that is the reason, if you wanted to create a new application now with the help of the cloud platforms, it becomes very easy. If you wanted to create an infrastructure, whatever that is mentioned by the architecture diagram, a DevOps engineer will directly go to the cloud platform and they will create the infrastructure in within few minutes itself nowadays. So earlier we were taking months, even sometimes quarters, 4 months, 5 months, 6 months. Also it will take when you are working in a traditional working model. But when you are working in the cloud, you are not taking a lot of time. It hardly takes few minutes only for you to create the infrastructure by the DevOps engineers. Okay, so that is how one of the major advantage that you are going to get, so which leads to the faster deployments. So that is the reason the CI/CD came into the picture, the DevOps engineers came into the picture. So they are going to create the infrastructure very faster. You are going to, the application team is going to be deploying the things very faster. So the advantage is that you do not have a slower deployment model. You do not have a slower deployment model. It is because the deployments are faster, because you don't need to rely on any of these people now. You can directly straight away go to the cloud provider and create your infrastructure and deploy your code. So that is the reason the faster deployments will be there. And one more thing is that when you do not have a data center maintenance, There is no such things of like this. So the overall cost to maintain your application or deployment of your application is little bit less when it compared to the traditional model in the cloud computing model. Okay, so that is the reason most of the people say is that cloud is cheaper than the traditional one. Okay, so that is how you do not have a expensive working model. Traditional model was expensive, but the cloud computing model is a comparatively less expensive. And you, if you look at the cloud works everything via APIs, application programming interfaces. When you are working everything via APIs, making automated becomes very, very easy, I would say. It becomes very easy for you to automate the things. Okay, so automation becomes very easy now. If you wanted to deploy your infrastructure, manage the infrastructure, version the infrastructure, or upgrade the infrastructure. So that is the reason the all limited automation was not there in the cloud computing model, because you can easily automate most of the things. Okay, so that is also there. Now you do not have many teams. Look at here, earlier we used to have this many, this team is there, this team is there, this team was there, this team was there. But now you do not have a plenty of teams. You don't need to work on different tasks on different teams. The chances of human error is very less, which does not lead to the inconsistency in the environment. Okay, there will be a human error, but that will be very less compared to the traditional working model. And wasted resources. So whatever the advantage with the cloud is that whatever the infrastructure that is required for you, you are going to create that infrastructure only. You are going to create that much of infrastructure only. So that means you are going to utilize the compute resources properly. You are going to utilize the compute resources properly. So that's the reason the wasted resources are less in traditional, in less in cloud computing model compared to the traditional working model. In traditional working model, you are going to you are going to waste the resources little bit more compared to the cloud computing model. Okay, so these are the advantages. That's the reason most of the companies are looking towards the cloud platforms to make the advantage of all of these things, because every company wanted to deploy their applications faster. They want a less expensive model. They wanted to automate everything, and they wanted to have a less human error, less inconsistency in the environment, and they wanted to utilize the compute resources properly. So that is the reason most of the companies have started using the cloud computing model. So those cloud computing models are like AWS, Azure, and GCP. And in our course, we are mainly focusing on the GCP. So this is what is the cloud platforms, guys. So this is the difference between the cloud computing model as well as traditional working model. In a simple words, sir, if you ask me what is the difference between the traditional working model as well as cloud computing model, in a traditional working model or in an on-premises working model, a company or an organization has to manage their own infrastructure for running their applications or code. In a simple words, if I have to say, an organization managing its own infrastructure for running their code or application is nothing but a traditional working model. What is meant by infrastructure? If you ask me, sir, a server or a hardware or a software or a networking or a storage. If an organization managing its own infrastructure for running their application or a code, then you can call that as a traditional working model. If an organization is depending on the infrastructure provided by the cloud provider, that company you can call it as a cloud computing model. In a cloud computing model, you have a cloud provider, they deliver you the infrastructure as a service to you. You are going to utilize those services. In a cloud computing model, it's like renting the resources. You are going to rent the resources for some period, and you are going to rent it, so you are going to utilize it for your own project purpose. You are going to utilize it for your own project purpose. So this is what is the difference between the on-premises working model as well as the cloud computing model. So the difference is that in a simple words, it's like cooking a food at home. So if you wanted to eat a food, there are two ways. You can cook a food at home, or what is that one more thing, guys? If you wanted to eat a food, what you can do? One more thing. Can you guys tell me? Instead of cooking a food at home,
Order from Zomato.
we can go for the restaurants, or we can order the food. So restaurants are like cloud computing model. So when you are cooking a food at home, you have to take care of the stove, you have to take care of the utensils, you have to take care of the rice, you have to take care of all the necessity vegetables, all the supplies you need to take care of on your own. Yes or no? So that is what we call as a on-premises working model. You have to take care of all the things. But when you go for a restaurant, you can just order the food. The food will be at your step. Okay, you can directly have the food. You don't need to cook it. So that's what the main difference between the on-premises working model and cloud computing model is, that in an on-premises, the company has to manage their own infrastructure. In a cloud computing model, cloud provider will take care of the infrastructure. Your companies focus on the innovation. Okay, so this is what is the main difference between the traditional working model as well as cloud computing model. Okay, so this we will see, guys, later. So I will talk about this slide later when we are started with the GCP resources. Okay, so before that, if anyone have any questions on the topic, that is why we need the cloud platform, you can ask me, guys. If anyone have any questions, please raise your hand. Whenever you have any question, you have to raise your hand, guys, so that I will go one by one. Okay. Yes, Vijay. So anything can be easily scalable. So if you wanted to create an application and manage it on your own, so that's what you call is a traditional working model. You can, if you wanted to scale it up, it is again a problem in the traditional. But if you wanted to scale it up in the cloud, it becomes very easy. So that is also one more thing that we have to consider, guys. Yes. Yeah. Scalability is also one of the major thing that we have to consider, guys. So because traditional systems are less scalable, we can scale it, but it takes time. But for the cloud models, if you wanted to scale it, it's in your hands, because most of the services in the cloud platforms are auto scalable. Scaling up and down can be easily done. Okay, so that is what it is, guys. Yep.
Sir, what is the
So
difference between different cloud service model like infrastructure as a service or platform as a service?
it's very easy. So if you go, so infrastructure as a service. Okay, so the entire infrastructure is provided to you. Okay, that we will be seeing. So that is what I have mentioned here. So here it is infrastructure as a service, platform as a service, as well as software as a service. That I will tell you later, guys, because when there is a need, you will understand even more better. So I don't wanted to talk about that here, because you can easily forget at this point of time. But when I talk about that particular service, and if I talk about, okay, this is what it is doing, and with the help of this one, we are going to discuss, we are going to manage this much amount of infrastructure. So this is comes under this category, this is comes under this category. If I say, you can easily understand it. Okay, yeah, I will talk about there. Yeah. Okay, so now let me gonna just define Google Cloud Platform one more time, guys. Yesterday also we have defined it, and let us try to do it one more time. Google Cloud Platform is a suite of cloud computing provider. It provides you the wide range of services or solutions for the organizations to build the application, deploy the application, and scale the applications and services in the cloud. It's very simple. It is a cloud provider, provides you the cloud computing services. That's it. And what are the services it provides you? If you ask me, it provides you the compute services. It provides you this service, networking, all of these things, big data and machine learning and storage and database. So this is for all the people. Sir, if you wanted to become a data engineer, we are going to focus on this one. We are going to focus on this one. We are going to focus on the storage and database services. We are going to focus on a big data services. So you can also call this as a GCP big data engineer, GCP data engineer. Both are same, sir. There isn't any difference between that. Okay.
No, are you focusing on machine learning?
No, we are not covering machine learning. As I have told you yesterday, the course curriculum also. If you guys have any questions, you can just go back to the course curriculum.
GCP data engineering, everything will going through Vertex engineer, Vertex will base actually deployments on
So we are not covering the machine learning. Yes. Okay. Yeah. That topics are not covered here, guys. So we will be mainly focusing on GCP data engineering only. So machine learning topics are not covered here. Yeah. Yes. Anyone have any questions, please? Okay, Google Cloud Platform. So Google Cloud Platform is a cloud provider. It provides you the cloud computing services. These services are highly reliable, secure, and it provides you the scalable infrastructure. If you wanted to scale up the infrastructure as per the requirement, you can easily scale up and down as per the demand. And this infrastructure is available throughout the world. You can easily select wherever you wanted to create this infrastructure because it is having the network and data center globally. Okay, so that is what it is. And we will see even in India also we have like two places in Mumbai as well as Delhi. We have the data centers for the GCP. In Mumbai as well as Delhi, we have the data centers for the GCP. Who is that? Yes, Sagar. Yeah. Yes, I have told you that only yesterday. Those who have missed the yesterday session, please watch the yesterday session, guys. So AWS data engineer, Azure data engineer, GCP data engineer. Okay, because these are the different cloud platforms. A data engineer can work in the AWS, can work in the Azure, can work in the GCP. This course we are going to focus on the GCP data engineer. Okay.
So
Yeah.
if you are comfortable with GCP, then it's possible to be AWS and to be Azure.
Yeah, if you are working at one cloud platform, you can easily learn other cloud platforms as well.
So there's
Okay.
Azure Data Factory and all something is to be different.
Okay, let me gonna tell you guys in a simple words what topics we are going to cover. So that seems like people have joined today only. So let me gonna tell you in a simple words what and all topics that we are going to cover in 2 minutes. Okay. So, sir, in Google Cloud Platform, we are going to cover yesterday's demo. It was, guys, whoever missed it, you can watch the video if you wanted to have a full information on the topics and everything. But high level, I'm telling you, we are going to cover the Google Cloud Storage. Okay, so this is one of the cloud storage in the Google Cloud Platform. That is one, Cloud SQL 2, BigQuery 3, Bigtable 4. So 1, 2, 3, 4. These are all comes under the storage and database services. And the next set of services is that we are going to cover Dataproc and Dataproc for the Spark and Hadoop. Here we are going to learn about the PySpark. And data flow. Here I'm going to teach you about the Beam, Apache Beam with Python. Here we are going to, I'm going to teach you the Beam, Apache Beam, how to create the Beam pipelines. Here we are going to see how to create the Spark pipelines, how to run the Spark pipelines. Data fusion without writing any code. If you wanted to create a pipelines, you have a data fusion. So this is your it is 5, 6, 7. And we have a workflow orchestration tool that is 8. So in Google Cloud Platform, if you wanted to learn about the workflow orchestration, we are going to cover the Airflow that is there in the Google Cloud Platform called as Composer. We are going to cover. That is our 8th service. And the next thing is PubSub for the streaming data ingestion, which is similar to the Kafka. And we have a cloud functions for event-based solution. So we have cloud functions that is 10. A bonus topic for you that is Terraform, that is 11. And for this course, It's a bonus topics for you is that I am going to cover you the Linux basics as well as Python crash course. Okay, so I'm going to teach you the Python also for 6 to 7 days, guys, where you are going to learn about the Python required for the data engineers. So all of these concepts that we are going to cover, guys, in this entire GCP data engineering course, including the cloud basics. I forgot to tell you the cloud basics. So the cloud basics are here. So we are going to start with the cloud basics. Sorry, the cloud basics today we started with this one, and we also seen yesterday this one, right? So these two things we are at covering now, 1 and 2. So cloud basics, cloud overview, and GCP introduction. Tomorrow I am going to talk about the GCP interfaces, free account creation, project setup, enabling the building and API. We are going to cover the GCP locations, regions and zones, IAM and admin. So all of these things, once the cloud basics are completed, we are going to jump onto the GCP data engineering tools, GCS, Bigtable, Cloud SQL, all of these things. Okay. Yeah, this is all about the course curriculum, guys. And course timings will be the same thing, 9 p.m. to 10 p.m. every day. Okay, every day we will be having 9 p.m. to 10 p.m. If you have any questions on the course fee, you can connect with the admin. Okay, yeah. Anyone have any other question on the course, guys? Okay, yeah, because from tomorrow onwards the sessions will be regular. Today and yesterday maybe I'm talking more about the course curriculum. Please allow me, guys. Some people who have joined yesterday and they may be having the repeated topics today also, please allow me today, because there are few new people. But for tomorrow onwards the topics will be regular. Okay, so we will not be talking about the curriculum and all. Tomorrow onwards we are going to talk about this one. So we will
How
be
the
proceeding further.
opportunities for the data engineering, if you don't mind, with the first class actually. So if you
For
talk
the
about
GCP data engineer, you have a plenty of opportunities, so you can easily learn the course. The calls are there, so when you have a call, so you will be having a plenty of opportunities. So if you wanted to go for a job, it's easy with the GCP data engineer compared to the AWS and Azure.
so
Okay,
is it for freshers or maybe
it's not for the freshers, guys. Okay, this course is not freshers, so I can tell you freshers also, but I don't want it to fake it. So I'm telling you guys, this course, whoever is having minimum 3 years of experience, I would say 2.5 to 3, but minimum 3 years to whoever is having, you can go for this course. You can put it in your resume, you can go for the job. Okay, minimum 3 years. It's not for the freshers. Freshers is an added advantage to you if you wanted to put in your resume, so that it is like a upskill for you. Okay, for those people who wanted to go for the job, you should be having at least 3 years of experience. And we are going to tell you how to create the resumes. I'm going to give you how to create your resume and how to go for an interview for the project 1 and project 2 explanation. And we are also providing you the data engineering questions. So everything is properly planned. You don't need to worry about it. This course will be having everything. Okay.
so do you need any background is required for the any technical
SQL
knowledge?
is prerequisite, guys. So SQL is the prerequisite for this course.
SQL is required.
Yes.
Okay, you're not teaching SQL, right?
Nope. Okay. I hope this is clear. Anyone have any questions?
No, one more thing. Do you need additional knowledge? Anything? Only but GCP will not be work, right?
No.
So
No.
on-premises work may be available.
Sorry, Raghavendra. Sorry, your question is not audible for me. Sorry.
So if you have in the real time,
1 minute. 1 minute. Gangadhar, 1 minute, please. Yes, Raghavendra. GCP is what? Real time? Yes, this is big data only. Yeah. These are big data concepts only. BigQuery is a big data tool. Dataproc is a big data. Dataflow is a big data. PubSub is a big data. Airflow is a big data. Okay, you can go and see here also. This. Okay, let me gonna show you here. So this diagram I have not created. Okay, this I have just copied from the Google public documentation itself. You can see here. BigQuery is a big data tool, right? Cloud Dataflow is a big data tool. Dataproc is a big data tool. PubSub is a big data tool. Okay, so we are covering the big data. Composer will also be there. They have not mentioned all the things. Composer will also comes under the big data. Okay, yeah. So these are storage and database services, cloud storage, Bigtable, Cloud SQL, all of these things are storage and database services. Okay, yeah. Yes, Sarita. Correct. Yep. Correct. Correct. Yes, yes, of course. So whatever I am teaching here, maybe so you can think like this, guys. So if you are learning one cloud platform, that means you are learning the other cloud platforms as well. When you go and work in other cloud platforms, you just have to know the interface. All other things becomes very easy. So in this course, I should tell you, okay, I'm gonna tell you guys. So we will be teaching Linux, Python, and one more thing. Sorry. One more thing is PySpark also we are teaching. Okay, PySpark also we are teaching. Okay, so usually I don't mention it here, but so those people who does not know it, so PySpark concepts are covered. Concepts are covered. Not only that, so there's a one more thing is also there, that is Apache Beam. Okay, so if you wanted to create the Beam pipelines, you should also know about the Beam pipelines as well. So all of these concepts are covered. You don't need to worry about it. So if you are learning these concepts in this Google Cloud platform, these are applicable to other cloud platform as well. Okay, so that's how it works. Yeah, and this duration for the course is 2 months, guys. 2 months is the duration for the course. Yeah. Yes. Any other questions, anyone, please?
How it is real time is be for the 3 years experience, we will be programming based come kind of thing.
So this course is helpful for those people who's having experience at least 3 years. And one more thing is that how we are going to manage it with help of the projects. So I am going to give you the project end-to-end project here, and we are going to cover the BigQuery case studies and assignments and data proc case study and end-to-end pipelines, data flow template method, that is nothing but a case studies, end-to-end streaming pipeline, and airflow I mean the workflow orchestration 1, orchestration 2, orchestration 3, or orchestration 4. You can think of like a, these are all different case studies or use cases you can think of. So this knowledge is more than enough for a 2.5 years of guy, or 2.5 to 3 years of a guy who worked on the GCP. So that much level of experience that we are going to cover. And in one of the cloud composer, we are going to give you, I'm going to teach you a cloud DevOps flavor as well, where you are going to automate the CI/CD. Okay, so if you wanted to implement a CI/CD with help of the composer, so how do we do that with the help of the cloud build and GitHub and Visual Studio Code and code pushing Git commands, how you are going to do it? So that I'm going to teach you in this particular aspect, so that you get some kind of understanding of how people are working in the CI/CD also, so that you get some idea of in your real time how people actually as a data engineer, how they actually support for the DevOps as well as CI/CD also, you will get to know. Okay, yeah. So for practice this entire thing, I am going to tell you how to create a free tier account as well. Okay, guys, so if you guys have any questions, please raise your hand, okay, so that I'll get to know who is asking. Okay. No, I am not able to hear you guys. So please raise your hand if you guys have any questions. I will go one by one. Okay. So please raise your hand. You have a raise button here, so that I'll get to know who is actually asking, so that it will be easy for me. Okay.
Uh,
No. Wait a minute.
Hello.
Wait a minute, guys. Yes, Yashwant, you have any question? Okay. 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 So that's thing. Okay, Yashwant, I'll tell you one thing. Okay. So you have to fix for yourself that you wanted to become a data engineer or not. Okay. If you wanted to become a data engineer, all hurdles you can able to easily Okay, you can able to easily come up. So the only thing you have to put is that you already know the problem is you already know. That means 50% of your problem is fixed, that you know this problem. The problem is that you do not know the coding. You can spend some time, effort, put your effort, learn the coding. Okay, you know the requisite for this course is SQL only. You come for the SQL. All other things like Python, PySpark, Beam, we are going to teach in the course, right? So you don't need to worry about it. So, okay, I hope your question is answered. Of course, you have, it's not about the managing, you have to learn. If I'm teaching, you have to learn. You learn, you practice, you get knowledge, then you go for job and you do it. Okay? So it's not that I can tell you, okay, if I'm teaching something and you can easily learn, and that's not, I'm not going to tell you. You have to put the effort. If I'm putting, so for this course, guys, for this course, if I'm putting, I'll deliver you almost 70% of the knowledge to you guys. I'll transfer my knowledge to you 70%. Rest of the 30% on you, that how you are going to take it. How you are going to take it to the next level. You have to take it by learning every day, by putting your effort every day. You have to invest the time. If you're not investing the time, if you are only ready to invest the money, it is not going to give you any result. Okay, two things is required from you: invest your time, invest your money, invest your effort. If you put all of these things, I am telling you, you can easily get the job. If you're not able to do that, I suggest you to not to join the course. Okay. So if you are ready to get the job, sir, I want to get the job, effort and money as well as the time, you have to do that. Yes. Next question, Sarita, you have any question? Those whose questions are answered, please lower your hand, guys. Yeah. Yes, Sarita. Correct. In general IT experience we are talking about. So that is how, what our plan is that. So this is my plan, sir, for all of you guys. Sir, I have 3 years of experience, because minimum 3 years, as I told you. This is my plan, sir, for all of you. You have to please pay attention. Don't ask this question one more time. Okay. So that 3 years, for example, sir, I have 3 years. Sir, I have, some people will be having 5 years. Sir, some people will be having 7 years. Some people will be having 10 plus years also. 3 years. Last 2 years in your resume, whatever you have worked on, don't worry about it. Whatever you have worked on, that 3 years, you put that as a 1 year. Last 2 years, you put as a, I worked as a last 2 years as a GCP data engineer. If you have 5 years, again put 2 years. Last 2 years, again GCP data engineer. You have, if you have 7 years, last 2.5 years, I have worked on GCP data engineer. If you have 10 plus years also, last 3 years, I worked on GCP data engineer. Okay. So you now know how to prepare your resume. You remove your 3 years. When I 3 years, that 1 year, you have to put any other experience, but last 2 years, you have to prepare your resume like this. For 3 years, you put any other experience, but last 2 years, you have to put GCP only. So something like that, you have to create your resume. To create that also, I made your job even more easy by looking at this resume. You can do that. Okay, you can go to this resume. For example, let me gonna show you one of the resume. Okay, so let me gonna show you one of the resume. So I have like plenty of people's resumes here, guys. So recently, this guy got the job, Narasimha. Only 4 years of experience. His package was around 3 only, guys. Okay, his package was around 3 only. Now he got like 9.5. Okay, 9.5 something, 9 plus something, I'm not totally sure. You can see here. Okay, what we have done is that, so his experience, we have put it as something like okay, this experience. So whatever we have put, so he earlier he has some basic experience on the SQL. So that's the reason I mentioned here some SQL experience. And later we mentioned the 2013 to 2024, everything as GCP. Here also 21 to 23, everything as GCP. So that means last 2 years, last 2.5 years, we put as a GCP data engineer. Others is something that whatever you wanted to mention. If you are coming from testing background, you put your testing background that 2 years. Okay. So for example here, sir, I am coming from 3 years. So 1 year you put from the testing and 2 years from here. So I come from business intelligence. You put 1 year from the business intelligence, 1 year from the ETL, 1 year from the database, but database admin. Last 2 years you have to put as a GCP data engineer. How you have to manage? In my current company, we are having a team building. So there I got an opportunity to work as a GCP data engineer because I was already familiar with that. I took a course and I have learned that and I joined in that company. From last 2 years, I'm working as a GCP data engineer. Now, if you go for interview, I am telling you, my students are very confident in the interviews. They are able to easily answer all the questions theoretically and practically. Okay, so you don't need to answer all the 10 questions if they are asking. If you are able to answer at least 8 questions confidently, 7 questions confidently, if you are able to manage the other 3 questions confidently, that's totally enough to get the job. Okay, so this is how it is, guys. So this is the formula. Now, I think most of the people have this question. I have cleared it out. Okay. Yes, Ishwar. You have any question? Yeah, correct. Correct. Okay. That's not a problem.
Phone there.
That- That's not at all a problem. Okay. So if you have a testing, sir, I say so. Some people will be having this one. So they're worried about the role, right? You are talking about the role, right? So in my offer letter or in my designation, I have mentioned as a testing, sir. Okay. Some people is having something like analyst, business analyst or something. Some people will be having some ETL developer or something. Okay, what you have to say is that, yeah, I am working in a testing background, testing department, but our main work is to data engineering only. Okay, first thing, no one asked this question. No one ever will ask this question. You will only tell me that after attending multiple interviews, sir, I worried about the role, but no one even worried about asking this question also. Because no one will ask the question that you were working on a testing, then you are joined in the this one, or in your offer letter it is like this, but you are coming as a this one. So no one will ask these questions. Okay, so whatever you mention, they will allow it. Okay, so that is how. They don't worry about the previous experience. They will ask you what you are doing in the previous, but they will don't go for the documents and check it. Okay, so that is how. So you don't need to worry about the roles, guys. You can easily manage it. You can say that I was working as a testing, but later point of time, last 2 years, I was working on the GCP in the testing department or something. Analyst in my company, our data engineers also called as an analyst only. This is happens in some most of the companies. In my company, even though GCP data engineer, every data engineer comes under the ETL background only. So I will be getting a ETL developer only. Software developer, some people get it. So even though some data engineers get a role as a software developer, so you can't say that. You have to tell it them. So in my company, we will mention senior software engineer. Okay, so that is how it works. So you don't need to worry about the roles, guys. That's not at all a problem. Yeah. So yes, Abhay. You have any question, Abhay? Oh, okay. Abhay, I can't hear you if you're asking something. If you are not able to ask properly, you can put your question in the chat also, guys. I'm at the chat as well. Yes. So even though if you're coming from non-programming background also, guys, you should be able to easily learn it. I'm telling you. Okay. The only thing is that you need to have a jail to learn the course. Okay. Yes, so Muhammad is asking one question, sir. Data processing services will be covered like data flow. Of course, it is covered. Okay, that is what I have mentioned just now, right? So the repository will be production ready kind. So it is may not be the production ready kind, but it will be that if a developer is developing a something, so however it will be, so it will be that much only. It's not that production ready, because we don't worry about how to create the parameters and all of those things. We'll give you, but we are not going to worry on much on that, because we mainly focus on the development instead of making it on a production level. Okay, so we need to focus on the development. Yes, Abhay, yes. Uh-huh. Okay. So this is what the people, most of the people do a mistake is that. So, sir, a data scientist is a very vast area. Okay, data scientist is a very, very vast area that you can't become a data scientist in 1 or 3 months, or it is not possible even 6 months also. You have to put a lot of effort, at least 1.6 months. I would say at least 1 year. Okay, so even though you learn one course by 1 year and you can become a good data scientist, I would say no, it's not possible, because you need to have a very good foundational things, that is data engineering. Data engineering is a foundation, guys. I'm telling you, data engineering is the foundational thing for most of the things. If it is for machine learning, if you wanted to go for data scientist or analyst, data analyst, whoever you are, if you wanted to get the foundation, so the data engineering is the foundation. Okay, so all the concepts like SQL, Python, PySpark, Spark, all the concepts of processing, everything covered here. And you are going to go with wherever you are. Even though you ask some machine learning engineers also, they will use this SQL, Python, PySpark, Spark, and all of those things. They will say that we will be mainly using 50% of the tools of data engineering, other 50% is machine learning. Okay, so that's what the correct. Correct. Those pipelines we are creating it here. Yeah, it's a paid one. Yeah, we will provide you the details. Don't worry. You will get a call. Yeah, from the admin you will get a call. Don't worry about that. Yeah, for sure. You might have provided your number while you are registering for this Zoom link, right? I think, yeah, you will for sure by tomorrow you will get a call and they will provide you all the details. Okay, so and for the brochure for the course curriculum, you can look at the chart. You have the data engineering.pdf is there. That is the course curriculum for this course. Okay. Yeah, this course is with a decent price only, so it's not that much also. You can think by when you go outside, like you might be looking at when you say data scientist, machine learning, data engineering, if you go for some institute, they will say 30K, 40K, 50K. It's very less here, around 12, 13, 14K only here, guys. Okay, don't worry about that. Yeah. Yes, Naveen Reddy, you have any question? You are not going to familiar. We are not here to familiar with anything. We are going to learn it. We are going to practice it. We are going to get perfect here. Okay, so this course is not to get familiar things. This course is not to learn the basics. Okay, we will be starting at basics and we'll go for the advanced things, because that is the course is about. Because we wanted to become a, eventually we wanted to become a data engineer after 2 or 3 months. Okay, so basics does not give you anything. If you have 3 years of experience, it will not give you the job. You don't get the offer at all if you have a basics. The only thing is that basics with the implementations and practice will give you the job. So what we have to do, while if I am teaching today Python some concepts, you go here and practice it, and even you explore it, you go for even more questions and practice it, get perfect with it. Okay, I'll give you the assignments, you practice it, you try to complete it, you ask for me the answer, I will give you the answer, you verify whether your answer is correct or not. So that's how you get perfect. Okay. Yeah. Okay. Okay. Okay.
Hello.
That we will be there. See, you are already coming from the same background. You are worried about it. I would say that you don't need to worry about it all that much. You can say it's because there's one of the guy who is was asking very simply saying that, sir, I do not know coding at all. I'm coming from a mechanical background, but I still ready to learn it. So, but sir, can you guide me? So that was a question that he does not know about the coding at all and depth of the coding at all. But you already know the depth of coding, right? So it's easy for you, I would say. It's easy for you if you put effort. You have to put little bit effort, okay? Of course, of course. Why not? Of course, that's what I'm saying. You are going to, you can expect the real time things because if I'm not teaching you the real time things, why would you become a good data engineer? Okay, so because if I wanted to become a good teacher, I should explain you the current scenarios. My notebook will always every day gets updated. It's because that so every day when I'm teaching something, I come up with a one more new thing, and I will come here and I will update it. So earlier I was not teaching Python. People suggested me that, sir, whenever we are going for the interview, they are asking more on Python. Sir, can you add the Python also here? So that's where the students told me that, sir, I will. Students told me to add the Python crash course at least. So that's where I have added the Python crash course, which is of 7 days. Okay, so I cannot teach you. I would say that the data engineering we are not covering Python. So even the people will still join the course, but I don't want it to provide you that because if you wanted to become a good data engineer, you learn all the things. Okay. Yeah. Yes. Yeah. Thank you, guys. Yeah. Okay. I see that most of the questions were answered. I'm really sorry, guys. Some people might be expecting that we are starting a real-time topics. I mean, the real topics today, but I couldn't able to start it. But for sure, tomorrow onwards, I will be starting the real things. You are going to. I'm going to open the Google Cloud platform. So far, I have not opened the Google Cloud platform. I think I was expecting at least one of the guys should ask me, sir, how the Google Cloud platform looks like. So how we are going to work with each and every service. This is my Google Cloud platform, guys. So I will tell you how to create a free tier account. This is my free tier account only. So you can see here, guys, I was awarded with almost 3,000 okay, 30,000 free credits. So these are all free credits only because I am in a free trial. I will also teach you. See here, even though I am teaching multiple batches, almost 21 days completed, I still only used 4,000. I've been teaching almost 5 to 6 batches on this thing from the last 21 days. I hardly used 4,000. By the end of the your 90 days also, you are not going to utilize even 10,000 also. Okay, even 10,000 also. I would say multiple people can work on a single account as well. That's possible. Okay, so I will tell you how to create this free tier account. So all of these services are here only. I was teaching you, I was telling you, right? So the solutions, more than 2000 solutions are there in the Google Cloud platform. So management, compute services, storage and cloud storage, storage transfer services, analytics, BigQuery, PubSub, data flow, Composer, data proc, data fusion, all of these things are here. So these are the plenty of the services are already available. One day when we have it, we have a one topic, right? So we will be having a one topic here, console walkthrough. Here I am going to teach you about all the things. So how you have to access this Google Cloud platform, how where you have to go for working with each and every service, how to create these projects, how to enable the billing, how to enable the API, and all of those things I am going to teach in one day, guys. Stay tuned. Okay. Yeah, maybe day after tomorrow. Okay, yeah. So this is it for today, guys. It's already 10:15. If anyone have any questions, you can ask me. Otherwise, I think we can wind up the session. Tomorrow, we are going to talk about this one, GCP interfaces. Okay, so this is what we are going to talk about, the GCP interfaces, guys, tomorrow. Okay, yeah. if you wanted to go for a certification, it's all around 8,000 for associate cloud engineer. Okay, there are two certifications you can actually go for: associate cloud engineer as well as a professional data engineer. So associate is around 8,000, professional is around 12,000, I guess. So I'm certified, guys. I'm also certified. Professional data engineer is around 12 to 15,000, I believe. Certification exam. Yeah, yeah. If you are planning for a certification, you can ask your company. Yes, yes, in the PSN. Yeah, you have to register for it. Correct. Okay. So how will be the career by choosing the GCP data engineer? I'm telling you guys. So GCP data engineer, GCP is having a plenty of opportunities for you. It will be going to be the demanding future only. So your role will be a demanding one only. So people who started GCP data engineer at some point of time, people does not know about the GCP, but the companies forced them to use the GCP from the last 1.5 year onwards, and now they are very much interested by many of the companies, because at least 1 year 2 years people are looking for that. Okay, so people were forced to use the GCP from the last 2 years, but those people now are earning like anything, even though they are having 3 years 4 years experience also. Okay, so now such kind of a demand is there for the GCP data engineer. Your career will be progressive, you don't need to worry about it. Yeah. Okay. Yes, Rohan. Okay. No, no. In this course, we are not covering the DevOps topics. Yeah. Yes. So yes, Mohammed, I'll just told you, right? So I'll be telling you how to create a free tier account. So there is that. So curriculum details, I have already told you the curriculum details. So let me gonna give you the curriculum link for those people who need the course. So here you have the link for the course curriculum, guys. Okay. Yeah. Okay. I think you have the course curriculum here, guys. You guys can go and check it out. Okay. Okay, guys. Thank you all. Have a great day. I think this is it for today, guys. We are going to start our next topic, that is interfaces. GCP interfaces module 2. And we are going to see what is console, what is cloud shell, what is cloud SDK, and I will tell you how to work with each and every interface in tomorrow's session. Okay. Yeah. Okay, guys. Thank you all. This is it for today. We will meet tomorrow at the same time. Okay. Yeah. Stay tuned. Thank you, guys. Yeah.